In example 4, we're going to step it up just a little. We have a slightly more interesting numerator. We have to factor the denominator before we can break up our partial fractions. So what do we want? So I can work like this. Okay, so we have an 8x minus 1 over 2x plus 1 times x minus 1. If we're going to break that up into simpler fractions to help us integrate, we better hope that we had an x minus 1 as a denominator and a 2x plus 1 as a denominator. Next question is, what should our numerators be? And again, it's really simple. If you just have a nice linear denominator, you're always going to have a constant numerator. Remember, we're looking for those proper fractions. The degree of the numerator has to be smaller. It only gets weird when you have repeated factors, so like an x minus 1 squared or cubed, or those irreducible quadratics that you can't factor into simpler pieces. So first step here is clear fraction. So we want to imagine that we're multiplying both sides by 2x plus 1, x minus 1. It's just going to leave us the 8x minus 1 on the left. On the right, we're going to have an a multiplied by the x minus 1. The 2x plus 1's canceled. And the b multiplied by the 2x plus 1 because the x minus 1's canceled. And again, this one's a fairly straightforward one, so if you're comfortable, pause, try and work through this, and then check back. Do that with all of these until you hit something you're not sure about. So because we just have the nice linear factors, this should be another one where we can just use that first trick I've shown you and say, well, let's choose our x values wisely to see if we can wipe things out and find the values of a and b. And remember, the whole point is that this is true for any x. And this is actually kind of funny because if you look back up at where we started, x isn't allowed to equal 1 or negative 1/2, but still the algebra works on this to find those values of a and b. So we are okay to do this. If x equals 1, on the left I get 8 times 1 minus 1, so 7. On the right I get a times 0, which is going to go away. And then I get b times 2 times 1 plus 1, so b times 3, which means that b is going to equal 7 divided by 3. Okay, to find a, I'm going to do what I mentioned earlier. I'm going to let x equal negative 1/2. And that's going to give me, okay, so on the left, 8 times negative 1/2 is negative 4, minus 1 is negative 5. What am I doing? Negative 1/2. I get a times negative 3/2 plus b times 0. So the b part is gone. I need to multiply both sides of the equation by negative 2/3, so I'm going to get positive 10/3 for my a. So very careful on arithmetic so you don't mess everything else up by messing up just a silly thing here. This is going to leave me the integral from 2 to 5 of, okay, so a over 2x plus 1, a was 10/3. And then b over x minus 1, b was 7/3. So I'm going to get the 10/3, and then I have a 2x plus 1 in the denominator. So 1 over 2x plus 1. Since that's a first degree denominator, I am expecting to get natural logs. Again, if you're getting stuck on these and you need to work your way backwards out of them with a substitution, do it. There is a little bit of trial and error or careful paying attention that needs to happen here. If I'm going to get a 1 over 2x plus 1, I surely better have started with a natural log of the absolute value of 2x plus 1. But I need to be careful because if I tried to work backwards here and take the derivative, I would have a chain rule that would pop out an extra factor of 2. So I would get 10/3 times 1 over 2x plus 1, but then that would be multiplied by 2, which means here I need to make sure I've divided by 2 so that once I multiply it back in, I get my 10/3. So watch for chain rules. If there's anything multiplied by your x, you're going to have a little bit of a chain rule to correct for. The second one does not have anything big from the chain rule. The derivative of x minus 1 is just 1, so nothing weird's going to have to be corrected there. And then don't forget the plus c. And always, you should be able to check these. A lot of them you can check fairly quickly just by taking the derivative of your answer. Okay, thanks for watching.